Today we're talking about the equations that we'll be using throughout this course and how to rearrange variables to be able to solve for whatever variable you're looking for the answer for your problem. So we're going to learn a lot of different equations, and we need to remember the rules for rearranging variables. And so you may recall from algebra that whenever you have an equation where you have addition between two variables, to move one or the other variable to the other side of the equation, all you need to do is do the opposite of the operation that's happening. So right now, these are being added, so that means we need to subtract one or the other to the other side. So the example of that is here. If I want to move C to the other side, since it's already being added, all I have to do is subtract it. So A, the left side of the equation, minus C is equal to B plus C minus C. And when you add and subtract the same thing, it's basically just canceled out. So we're left over with A minus C equals B. Okay. Then, if we wanted to look at something a little bit more complicated like multiplication and division, we can do the same thing. So if you see two variables written next to each other, that means multiplication. You could see it written with a little times symbol or a star or a little dot, but a lot of times they'll just be written with nothing between them. That means multiplied. Okay? To do the opposite of multiplication, you have to divide, and that will allow you to move either one of these to the other side depending on which one you divide. So if we want to move B to the left side of the equation to get C by itself, we can divide on both sides by B, which is what has been done here. A, the left side divided by B, is equal to BC divided by B. And just like we said last week with unit conversions, anything divided by itself is equal to 1 and can cancel out. So if I cancel that out, I'm left with A over B equals C. Alright, same thing is true of division. Anytime you see a fraction like this, that represents division. So A is equal to x over y. This is division. If I want to move the denominator to the other side, all I have to do is multiply by it on both sides. This is really important. You cannot multiply by the numerator on both sides. The numerator is already essentially multiplied on this side, so you can't just multiply by the numerator. You can multiply by the denominator. So that's what we're doing here. A times y, since y was in the denominator here, we can multiply by it over here, and we can also multiply by it on the right side, and then y divided by itself cancels out. So we're left with A times y equals x, or if you write it without the dot, it's just ay equals x. Alright, then when we move to an example, let's say I'm doing a problem and it tells me that I need to find B. I might have values to plug in, and we'll get to that eventually, but let's just say I want to solve for B. I'm going to need to get B by itself, or isolate B. B is right here. Right now it's being multiplied by C. So to get it by itself, we need to move C away from it. Since these are multiplied, I need to divide C on both sides to move it, to get this over there away from B. So that means A divided by C equal to BC divided by C. And as you can see, this cancels and leaves me with A over C equals B. Now B is isolated, or solved for. And then that would allow us to plug in values for A and C and figure out the answer for B. Okay. Let's move to example 2 here. If we want to solve for Z, and Z is in the denominator here, we're going to need to get it away from all other variables. And remember, I told you we cannot multiply by the numerator on both sides. We have to multiply by the denominator. So that means I'm going to move Z. After that, Z will be over here, and then I'm going to have to move X away from Z to get Z by itself. So I'll show you what that looks like. X is equal to Y over Z. Since Z is in the denominator, I can multiply by it on both sides. So Z times Z, Z cancels here. So now I have Z times X equals Y. At this point, if I want Z by itself, I need to move X. These are multiplied, so I must divide by X on both sides. That crosses out, and I'm left with Z equals Y over X. This is our solved for Z. Z is now isolated. Okay. Now let's look at actually plugging values into an equation. Gotta get it straight. Okay. So let's say I had this problem that said if you made a 0.15 molar solution and you had 2.3 liters of it, how many moles are in it? Now I don't expect you to know what any of that means. All I want you to be able to do is look at this equation and figure out that the thing that had the unit, capital M, belongs here in the equation. The thing that has liters, capital L, belongs here in the equation. I would never give you an equation and not let you know what the variables mean. Okay? What are we solving for? We're solving for moles. The way you know that is it comes right after the question words. How many moles? Okay, so that means we are solving for moles. And in the equation, that looks like MOL. That means we're going to have to get moles by itself, or isolate. Okay, the things we're given are 0.15 M and 2.3 L. So I'm going to put that here. We're given that our M is 0.15 and that our L is 2.3. Okay, so then I can put those into the equation after I rearrange. So we already said we're going to need mole by itself. So right now, mole is being divided by liters. I want this by itself, so I have to move liters to the other side. This is a denominator, so I can easily move it by multiplying on both sides. M times L equals mole over L times L. L can cancel, and then I just get ML equals mole. All right, when we plug in, we're going to take our value for M and our value for L, and they're going to get put into these places, and then since these are just multiplied, we just take those numbers and we multiply them, and that gives us our answer. 0.15 times 2.3 equals mole. So then our answer is, I think I calculated this earlier, the answer is 0.345 mole. Remember, if we want to round to correct significant figures, this is two significant figures, so I can round this to 0.35 mole for my final answer. Mole is also a unit, so that's a little bit beyond what you guys would know. But if you just got the answer 0.35 for what we're talking about today, that's correct. Okay. Now we're going to move on to talking about density. Density is simply defined as the amount of stuff in a given area or a given volume. The stuff can also be considered mass. Okay, so it's the amount of mass in a volume. So for an example, we can look at these diagrams that I drew. Here I've got A and B. A and B have the same amount of volume or area or space they're taking up, but B has more stuff. Another word for stuff would be mass. Okay? Which one is more dense? The one that has more stuff or more mass in it with the same volume is more dense. So that means that B is more dense. Okay, if we look at the next one, I have this tiny little box and this big box. Each thing has 4 pieces of whatever stuff we're using. Okay, so they have same amount of mass, but they have different volumes. So this one has more volume. Okay, that means that the one that has more stuff packed into a smaller amount of space will be more dense. So A is more dense in this case. Okay. Turns out that the equation for density is density equals mass over volume. You've probably seen this before. We can also write it as D equals M over V. Now we just saw some other equations that we could rearrange, and we need to be able to do the same thing with our density equation. So in this problem, let's say we have an object with a mass of 152 grams and a volume of 12 milliliters. What is its density? Okay, what is? That tells you what we're looking for. We're looking for the density. So that means we need to solve for D. We are given mass of 152 grams. So we're given M equals 152 grams. And we're given volume equals 12 milliliters. V equals 12 ml. Do we need to rearrange the equation? No, because D is already all by itself in the equation without being rearranged. And we're trying to find D. So then all we have to do is plug in. Mass goes on the top, as shown up here. 152 grams over 12 milliliters. The answer we get for that one is, I wrote that down, 12.667. A whole bunch of sixes, actually. Pay attention to the unit. It's grams over milliliters. Does anything cancel? Nothing can cancel, so that means my unit should be grams over milliliters. Okay, now to round this to correct significant figures, we had 2 in this number and 3 in this number, so that means we need to round it to 2 significant figures. So after the 1, 2, I'll round right here. 6 rounds up, and I get 13 grams per milliliter for my final answer. Please make sure that you submit any questions you have to me about any of these problems. Okay, last one. We're going to get through this quickly, so I only have to make one video. All right, we have an object that weighs 290 grams, and its material's density is 7.3 grams per milliliter. What is its volume? Okay, what is volume? We're solving for V. What's our given? We have that the density is equal to 7.3 grams per milliliter. And we have that the weight or mass is 290 grams. That goes in the spot where our M is. Okay, do we need to rearrange the equation? Yes, we do, because we need V to be by itself. So D equals M over V. Remember, if something's in the denominator, we're going to have to move it first. And especially since we want V by itself, it can't be in the denominator by itself. So I'm going to multiply by V on both sides, and it cancels out over here. Then, once I have VD equals M, I still want V alone, so I'm going to divide on both sides by D to move it away from the V. D cancels here. So what we're left with is V equals M over D. Okay, and now we can plug in. I've got M over D, so 290 grams over 7.3 grams per milliliter. Notice here, grams divided by grams, those can cancel. And I'm left with my answer in just milliliters. That's all I have time for. The answer here would be